Oi lads, it's Danny here today, bringing you a lovely video. In today's video, we're going to take a look at a very interesting integral. The integral of 1 divided by x to the power of 2 plus 1 dx. What's that equal to? Right, before we jump into it, I want you to leave a like and subscribe. So, this is a very difficult integral. I'm going to show you how to navigate through it. So the first step you are going to need to do is we are going to basically expand the denominator using the sum of cubes formula. So when we do that, we can basically expand the denominator as shown on your screen before you. And from here, we are basically going to be applying a partial fraction. So we're going to basically break this integral in a series of partial fractions. It just allows us to make the integrals a lot easier to solve, because as it stands right now, it's very difficult. So by doing so, we are going to basically rewrite it like this. So we're going to separate the fractions as shown on the screen before you, and I'll go with partial fractions is basically to solve for the missing values a, b, and c found in the numerator. That's very important, and I'll show you how to solve for them. So first step is on the right hand side is that we need to obtain a common base. So we are going to basically multiply in a common base for this fraction and then this for this fraction, right? As you're going to notice straight away, they're going to have the same base all throughout the left hand side and the right hand side. So therefore we can cancel that out. And I'll go from here is to basically solve for our basically FOIL, right? Our numerators across both fractions, and then afterwards solve for the missing variables a, b, and c. So we can break them up in terms of variables that have x squared in them. So on the left hand side you have 0, and on the right hand side you have a plus b, because if you look here you have a over here and then you got b that has an x squared coefficient to it. So you have a plus b, and obviously we know that according to this that b is going to be equal to the negative version of itself, so negative a. For the x's we got this. And for just the numbers, basically no variables, just numbers, we have 1 is equal to a plus c. So this is basically a systems of equations on 3 accounts basically. And we are trying to solve for those variables as I mentioned. So we are just going to basically just rearrange them. And then afterwards, we are just going to try to find our a and b and c values. So the first one I'm going to tackle is the a term right away, and we know that when you solve for this you are going to obtain 1 divided by 3 is equal to a. For b, we know that b is going to be just a negative version of a, so that's going to be equal to negative 1 divided by 3, and for c you are going to have 2 divided by 3. So we can basically go back to our partial fraction as shown over here on your screen, and we're going to replace these quantities inside this partial fraction. So as is shown on the screen before you, we have done that. So right now, we have basically separated this fraction into two more easier fractions to solve. This is a lot easier to solve because you can split the integrals and just take the integral of one fraction at a time. Makes it a lot easier. But it's not at a point where it's very intuitive, especially on the right hand side. This fraction right here on the right hand side, it's very difficult to solve for. So we're going to try to make it more appealing so we can apply some sort of technique to, get it solvable. So like I want to do straight away, just try to make everything look nice. I want to move this 1 divided by 3 outside the integral. Like, let's move all the scalar quantities outside just to make it a lot easier to solve. You see there's a 1 divided by 3, that shows up here, and 1 that shows up there. So let's just move it outside. Just keep it out of there. Right, so you have this x minus 2 divided by x squared minus x plus 1. Already it looks much better. It looks actually much better to solve, but it's not quite at the stage where we can say, this is going to be easy to solve. So the next step, right, so we have gotten it in a format it's very, it's more familiar to deal with, right? But it's not at the point where we can fully say it's completely solvable. only the left-hand fraction looks solvable, the left-hand integral. Let's solve that, because that's actually very easy to solve. That just calls out for a basic U-substitution. So the way we solve for this integral, straightforward. You are going to take u is equal to x plus 1. You're going to take a derivative on both sides of this equation, very important. When you do that, you are going to have du is equal to dx. We are basically going to substitute that into our integral, and what you are going to have this standard integral to solve of 1 divided by u, which is equal to ln absolute value of x plus 1. We have solved for one integral. Now we got to solve for this integral, and this integral is a lot older to solve because we got to apply some special techniques to solve and some special tricks, and I'll show you the tricks basically, right? So this x minus 2 is the problem over here. That's the major problem, because we are going to take the u to be equal to x squared minus x plus 1, our u substitution. And the reason why we need to take the denominator as our u sub point is because the exponent is larger in the denominator than it is in the numerator. And when you take a derivative on both sides, you're going to see that the exponent degree gets lowered, right? So therefore you have to take it as your denominator, the u sub. And when you have it like this, you are going to have du is equal to 2x minus 1 dx. We can rewrite it in terms of, you can solve for dx basically, which is going to be equal to du divided by 2x minus 1. Now the thing is over here is that we need to eliminate this x minus 2, but we have du divided by 2x minus 1, right? When we basically substitute this in, and you can't really do anything at this point because they're not going to cancel out. So you need to basically manipulate this numerator so it looks exactly like this, so it can basically cancel out. And the trick we're going to apply here is some manipulation to the numerator. What do I mean by that? So we're going to take our x minus 2 and we're going to rewrite it so that we have a 2x minus 1. So what do I mean by that? So the way I'm going to do it is I'm going to basically, we know that 2 divided by 2 is equal to 1, right? We're going to write it like this, it's basically equivalent. We're just manipulating it, right? Afterwards, what we are going to do is take this 2 and we're going to multiply it inside the bracket basically. So when you do that, you are going to have this 1 divided by 2, 2x minus 4. Right, and we're almost getting there. You see, we're looking for 2x minus 1. So there's one more manipulation that you are going to need to do, and that is 1 divided by 2, open bracket, 2x minus 3 minus 1. Now we can rewrite it as this, which is 1 divided by 2, open bracket, 2x minus 1 close bracket minus 3 divided by 2. And notice straight away that this here is the same as this. So we can basically apply the u sub and cancel out the term basically. And now there's a problem with this, which you are going to notice straight away, is that we're going to have to break the integral in two. So the way we're going to rewrite the integral is as shown on the screen before you. We're going to actually have to break it in two, where we're going to have to break it in one fraction and another fraction over here, as shown on the screen before you. And over here I did 2 steps in one. I just moved the scalar quantities outside the integral. And now if we come back to this integral, let's focus on this one right over here. 2x minus 1 x squared 2x minus 1 divided by x squared minus x plus 1. Notice now when we apply the u sub, this is going to be the u sub, and look at what the dx is equal to du divided by 2x minus 1. This 2x minus 1 is going to cancel out, right? Let's take a look at it. I did it right here. Let's take a look. When you do the u sub, the same steps as before, you're going to have this. And we're going to substitute it back inside the integral. And notice 2x minus 1, numerator and denominator, they're going to cancel out. And what you are going to have is the integral of 1 divided by u du. Very important, which is equal to ln u. And what does u equal to? X squared minus x plus 1. And there you have it. You have solved for this section of the integral. That's it, basically. Now, we're going to rewrite the integral as shown over here, basically solving it. And we're going to basically, replace it in, right? And then basically multiply the 1 divided by 3 with 1 divided by 2, which is going to end up with negative 1 divided by 6. This integral, however, it hasn't been solved yet. And we are just going to basically from here, just going to multiply the scalars together. The 2's are going to cancel out. What you are going to have is this integral be written as shown. Well, it's partially solved, partially an integral has to be taken. So over here, looking at it, we are going to apply a special technique called completing the square form. Very, very, very important. And what is that? So looking at this, we're going to have a problem with it, because if we apply a U-sub, notice straight away, the exponent is going to go down by 1. In the numerator, you have a degree of 0. You have no exponent. So if you're going to go by 1 downwards, you're never going to match this. And that's the problem with this. So the way we do it is by applying a completing the square formula. So we're going to take this x squared minus x plus 1 and complete the square with it. So we're going to rewrite it in an equivalent format. So the way we need to do it is apply this formula, completing the square formula. And it's given by this. And the idea here is just to replace what the a, b, and c terms are inside this formula. It's very simple. When you do that, you can rewrite this formula as shown on the screen before you. And notice when you take a u-sub now, it's going to be, degree of 1. And then here you got degree of 0. So you come down basically. The u-sub is going to work. See why in a moment. But we have basically this to solve. And this here is a very easy and standard u-sub to solve for. We are basically just going to take a u to be equal to x minus 1 divided by 2 as shown, and take a derivative on both sides of this equation. When you do that, it's just going to be equal to du is equal to dx. We are basically going to substitute that into here basically. And what you have is this integral to solve, which is 1 divided by u squared plus open bracket square root of 3 divided by 2 squared. And at this point, you're going to have to apply another technique of integral calculus, which is the trig-substitution technique. So this integral is basically, we need to apply the trig-substitution, trig-sub basically, and it's basically one of these 3 cases. So looking at it, you could safely say that we got a case 2, because we got an a squared plus an x squared term. Right? They're being added. That's very important. So this technique tells us to use the trig sub as shown in the screen before you as x is equal to a tan of theta. So when you do that, we are basically going to replace our terms into here. Our a term is square root of 3 divided by 2 tan of theta. And then you take a derivative on both sides of this equation. That's basically the trig sub. And we are going to substitute that inside this integral. Very, very important. And as shown on the screen before you, this is what the integral becomes basically. Over here, you're going to apply a special trig identity. Oh, sorry, before you do that, you're basically going to factor out the scalar quantities because you don't want them inside this integral to solve. And we are going to then take a trig identity for the denominator. Tan squared of theta plus 1 is actually equal to secant squared of theta. So that's just going to cancel out, and it's going to be equal to the integral of 1 d theta plus this multiplying with the scalar quantity. But we're going to keep that outside for the moment. And what you are going to have when you take the integral of d theta is just theta. So you're going to have 2 divided by square root of 3 of theta, and there you have it. But we're not done yet because we're solving in terms of u, but ultimately we're solving in terms of x. So we need to get it back to u and then back to x. Very important. And what's theta equal to? We can rearrange our trig substitution in terms and solve for theta, which is given by this. So it's arctan 2u divided by square root of 3. Let's put it back into this, and there you have it. So you solved for the u term, but we have not solved in terms of the x term. And the way we gotta go all the way back from our u substitution, where we stated that u is equal to x minus 1 divided by 2. That's the key over here. And we're gonna substitute this back inside the equation, and that is the answer. So we basically solved for the integral of this basically. We are going to introduce it back into our final answer, and we just got to divide it, remove the scalar quantities that appear. You see here you have 1 divided by 2, and then you got 2 in the numerator. That's going to cancel out. And really the answer to this whole problem is basically solved. So that's it. Don't forget your plus C, and that's how you solve this type of integral. If you lot enjoyed this video, please drop a like and subscribe, and I'll see you lot later.